exactly, Kamla? Just confirm audio video is clear. Audio video is clear. Just confirm. A very good evening, everyone. Myself Prateek Mishra, and I welcome you all to the YouTube platform of IMS Gate Academy. We are conducting this series in which we are discussing all the PYQs of the previous years for the subject of structural analysis. In the yesterday's session, we have discussed the previous year questions asked for the year Gate 23 and 22. Today, we will going to see questions from the year 21 and 20. So, first of all, stay tuned to our channel to have all the concepts seen at one go. Thank you so much, Thiru sir. Okay. Second, my dear students, most important part is this is the month of November and this is the time where you should start focusing on your test series. IMS Gate Academy is conducting test series, and that too an online test series with an interface matching with the GATE examination. So link of the test series is in the description box. You can avail the facility of the test series by clicking in the link. We are providing you with more than 135 plus tests, including chapter test, subject test, multiple subject tests, advanced subject test, and the full length mock test. So my sincere advice is first of all, join our test series and have a proper analysis where you are lagging in understanding the concept, where you are making the silly mistakes, where you are making the calculation mistake. Even the calculator provided in our test series matches with the calculator provided in your GATE examination. So in order to have a proper feel of your GATE exam, I will personally recommend you to join our test series. Second, and the most important part, my dear students, we are having this Telegram group where regular updates regarding the technical exams conducted across the country is given to you. So you can join our Telegram group to having this information of the different examinations and also to enjoy the daily quizzes so that your technical knowledge keeps on improving every day on everyday basis. Moving to our session, my dear students, in this session, the things will be simple. I'll just ask you to solve a question. I'll give you 2 minutes of time. You can enjoy your concepts, apply them, and try to solve them, and keep answering all your answers in the chat box. So here is our first question, which is asked in the year Gate 21. Just go for this. 2 minutes timer is there for you. Try to solve this. Please share link of this session with all your friends so that they can even enjoy this information. So you are asked to draw the ILD for this propped cantilever beam for shear force at G. Try to solve it using Muller-Breslau principle. Okay, let's see this. So in the question, a propped cantilever beam EF is subjected to a unit moving load as shown in the figure. The sign convention for positive shear force at the left and right sides of any section is also shown. The correct qualitative nature of the influence line diagram of the shear force at G is. So whenever you get these type of questions in your exam, the only solution is your Muller-Breslau principle. It is one of the easiest principle to identify the shape of different influence line diagrams. So first of all, understand what do we mean by Muller-Breslau principle. For example, if this is my beam, so here I am given with a propped cantilever beam like this. This is my propped cantilever beam. This is E, this is F, and this is some G. Okay. It is given like this only, E, F and G, right? So I have to draw the ILD for shear force at G. Okay. So how to apply the Muller-Breslau principle? First of all, whenever I have to apply the Muller-Breslau principle for drawing the ILD for shear force, the nature of the shear force is to cut the member. Okay. So first of all, you just cut the member from G. And when you cut the member, you provide unit displacement at G. So when you provide the unit displacement, this member will go like this and this upper member will go like this. This is how you provide the unit displacement. You just join these two. So this displacement is your unit displacement. This displacement you are providing at G is your unit displacement. Now the deflected shape of the beam is the ILD for shear force at G. So this is minus, this is plus. So this deflected shape of beam is the ILD for shear force at G. Okay. So if I have to draw this clearly, I will draw like this. This is my beam. This is negative and this is positive. And this displacement is unit displacement. So this is your ILD for shear force at G. Okay. So you can just match with the previous 4 options, which option is matching, and that will be your correct answer. So when you match this, your option number B is matching with the ILD that we have obtained. So for this question, our option number B is our correct answer. So first, if you have to draw ILD for shear force, you need to cut the section. If you need to draw ILD for bending moment, assume the internal hinge at that point or at that section and give the unit rotation at that section. Okay. In the yesterday's session, we have did one such question where we have drawn ILD for bending moment for calculating the maximum bending moment with respect to moving load. In the yesterday session, you can watch that, right? For calculating or for having the influence line diagram for the support reaction, again, you thus remove the support reaction and give the unit displacement in the direction of support reaction. Then the deflected shape of the beam will be the ILD for support reaction, okay? So this is how we apply the Muller-Breslau principle. Moving on with the next question. This is again a question asked in the year GATE 2021. For structural analysis. Try to do it. Again, I'll give you 2 minutes of time. Try to solve it. You see, yesterday's session and today's session, we are getting regular questions from influence line diagram and truss analysis, which makes it one of the very, very important part of your structural analysis. So don't miss a question asked from these 2 areas because very easy, simple, and the level of question will be easy to moderate. Questions, calculations will be less. for these type of questions. So always do these questions. Okay. So a truss is given to us. We are asked to calculate the compressive stress in this member QR. This is QR. We are asked to calculate the compressive stress in this member QR. Okay. Till date, whichever question we have seen for truss analysis, we have calculated the member forces. But this time they have given us the area and moment of inertia, and they are asking us to calculate the stress developed in this member QR. So again, the process for solving a truss will be as we did for calculation of member forces. First step is calculate the support reaction, and then we will directly apply the method of sections to calculate the member force, and from the member force we can calculate the stress in the member. So let's see this. So you have load F, the value of load F is 10 root 3 kilonewton. So step 1 is calculate the support reaction at P and S. Okay, so I'll just take this. So this is my truss. So this is PQRST. This is PQRS, and then I have T. And at this, I have this force F acting. So step 1 is calculation of support reaction. So first is this support reaction Vp, and then I have HP. Here I have Vs. Okay. So the value of this force is 10 root 3 kilonewton. So first thing is, I'll take summation of moment about point S to be 0. So step 1 is calculation of support reactions. For that, I'll take summation of moment about point S equal to 0. So about point S, there will be two moments. First due to this VP and second one due to this F. The length of the member is, I think, also given to us. This is L and this is also L, right? And length is 2 meters. So this is 2 meters and this is also 2 meter. So when I write this moment equation, I have VP into 4 clockwise. So plus VP into 4 minus F into 2 equal to 0. This F will give a anti-clockwise moment about point S. So from here I can calculate the value of VP. So VP comes out to be F by 2. So this is 5 root 3 kilonewton. This is my VP. Now you can take summation of all the vertical forces equal to 0 to get the value of Vs. So doing that, summation of all the vertical forces equal to 0. So you have Vp minus F minus Vs is equal to 0. So Vp is F by 2. So Vs will also be F by 2. So Vs is also F by 2. This is again 5 root 3 kilonewton. You can take summation of horizontal forces equal to 0. So no external horizontal force is acting. Therefore, this support reaction HP will also be 0. So I'll write like this: summation of horizontal forces equal to 0. From here I can write HP is 0. Okay. This is 0. So this is the support reaction I have calculated. Now I want this member force QR. So again, there are two ways. First is method of joints, where you solve every joint and then you calculate the member force. Second one is your method of section, which is an easy and convenient portion. So what I will do is, I'll just consider one section like this. This is my section 1-1. And I'll consider the equilibrium of left side of this section. So considering equilibrium of left side of 1-1. So let me draw these members first. Okay. So this is my member QT. So force in the member QT will be tensile. I am assuming this to be tensile. This is FQT. The force in the member, this is Q. This is R. So I am assuming it to be compressive. This is FQR. And then this is P. This is PT. So I am assuming again to be tensile. This is FPT. I am only interested in calculating this member force QR. Okay. Rest is just for your explanation. This is your vertical support reaction VP. Horizontal support reaction is 0. And VP we know that it is 5 root 3 kilonewton. Okay. Now for calculating this FQR in one line, what I will do is, if I just extend this, right, these members are meeting at this point and this point is point T. Okay, you can just take this This is your point T. Even for this portion of the truss, I'll take summation of moment about point T to be equal to 0. So, I'll take summation of moment about T equal to 0. So, you have one moment due to this Vp coming in the clockwise direction about T, and that is equal to Vp into 2. There will be no moment due to this force Pt and force Qt. There will be only moment due to this force Qr, and that will be in an anti-clockwise direction. So, this is equal to minus Fqr. Now, observe this. I want this vertical distance. Okay, this is the lever arm for this force Qr. We know that length of all the members is same. So, this is an equilateral triangle, and if this length is L, this vertical height will be L sin theta. If this is L and this is 60 degrees, so this vertical height is equal to L sin theta, and theta is 60 degree. So, this is L sin 60 degrees. So, Fqr into L sin 60 degrees, and this should be equal to 0. Now, we know the value of L. L is 2 meters. So, I will write, just substitute all the values. So, Vp is 5 root 3 into 2 minus Fqr. Then you have L is 2, sin 60 is root 3 by 2, and this should be equal to 0. From here, you can very easily calculate the value of Fqr. So, this 2 and this 2 cancels out, this root 3 and this root 3 cancels out, and Fqr comes out to be 10 kilonewton. This is your Fqr. Okay. Now, we have calculated the member forces. The next step is calculation of the stress. So, stress in member Qr, or I will write sigma Qr, is equal to force in the member Qr divided by area of member Qr. So, let's check what is the area of member Qr. So, area of this member Qr is equals to 2A, and A is 10 raised to power, this is A, 10 raised to power 4 mm square. This is your A, and the area of this member Qr is 2A. So, area of member Qr is 2A. So, I will write down, this is Fqr is 10 kilonewton divided by 2 into 10 raised to power 4 mm square. We have to report the answer in kilonewton per meter square. So, convert this mm square into kilonewton into meter square. So, when you convert this mm square into meter square, it will be 10 raised to power minus 6. So, you can just write down, this is 1 times, this is 5 times. So, sigma Qr is equal to 5 kilonewton divided by 10 raised to power 4 into 10 raised to power minus 6 meter square. So, your sigma Qr comes out to be 500 kilonewton per meter square. This is your sigma Qr, and this is what asked in your question, right? Sigma Qr is 500 kilonewton per meter square. So, for this question, the compressive stress in the member Qr is 500 kilonewton per meter square. Many times, my dear students, we calculate the correct answer, but we usually don't check in which unit we have to put the answer. So, this is a very important part of your numerical answer type question, to check in which units we have to place the answer, right? The same answer can be calculated in Newton per mm square or Newton per meter square, But every time, especially for numerical answer type question, you always check in which units we have to put the answer. So in kilonewton per meter square, our answer will be 500 kilonewton per meter square, right? I hope you understood this solution. Let's move to the another question. Okay. This is again a question asked from truss, deflection of truss especially. Just go for it. Thank you, Richa. Keep answering. Keep answering, keep answering. Keep posting your answer in the chat box. Keep answering in the chat box. Keep answering. Okay. So this is a question asked from the deflection of trusses. Let's see this. A truss EFGH is shown in the figure in which all the members have the same axial rigidity R. If the figure P is, in the figure, P is the magnitude of the external horizontal forces acting at joints F and G. If R is 500 into 10 raised to power 3 kilonewton, R is the axial rigidity which is directly given to us as 500 into 10 raised to power 3 kilonewton. P is 150 kilonewton, length is 3 meters. What is the magnitude of horizontal displacement of joint G? Okay. So as soon as you realize that this is a question of joint displacement of a truss, the first method that should hit your mind is unit load method. That's all. Very easy method. Calculate the P values, that is all the member forces due to external load. Second, calculate K values, where you apply the unit load in the direction of desired deformation, and then you calculate the member forces. Then you calculate the axial rigidity and the length of the members you note down, and take the summation of PKL by AE, and directly you will get the deflection of that joint in the desired direction. Okay. So first of all, in order to solve this, step number 1 is very clear. Whenever we are solving truss, step 1 is calculate the support reaction. So I'll just draw this truss quickly and calculate the support reaction. So E, F, G, H and P load is given. So this is E, F, G and H, and load P is acting on the either side. Okay. So step 1 is very simple. Calculate the support reaction. Quickly tell me in the chat box what are the support reactions at E and H. Quickly. Just observing you should able to calculate all the support reactions. Okay, so let me assume the direction of support reactions like this. I'll assume vertical reaction at E in the downward direction. So this is VE. I'll assume the horizontal reaction at E in the outward direction. So this is HE. I'll assume vertical reaction at H in the vertically upward direction. So this is VH. Okay, this is a roller support, this is the hinge support. Now for calculating these vertical reactions, first I'll take moment about point H equal to 0. So for support reactions, for calculation of support reactions, take summation of moment about point H equal to 0. Okay. So about point H, there are three forces that will give the moment. First one is VE, second one is this load P, and third one is this load P. Okay. So due to VE, all these lengths are L. This is L and this is also L. All these lengths are L, right? So due to VE, moment about H is VE into L. So this is anti-clockwise. So minus VE into L. Then I have again an anti-clockwise moment due to this load P, and the value will be P into this vertical distance L, minus P into L. Then due to this load P, again I am going to have a moment about H, and that is a clockwise moment. So plus P into L. So from here, the value of VE comes out to be 0. This is my first support reaction VE. Now next equation is take the summation of all the vertical loads equal to 0. From there you can get the value of VH. So taking summation of all the vertical forces equal to 0. So you have VE in the downward direction. Then you have VH equal to 0. No other external load is acting. Since VE is 0, so VH will also be 0. So VH is 0. VH is 0, right? These are two support reactions. Now take the summation of horizontal forces equal to 0. From there you can get the value of HE. So I'll just write down here itself. Summation of horizontal forces is equal to 0. So from here you have minus HE minus P plus P equal to 0. So from here the value of HE is also 0. HE is also 0. Okay. So first we have calculated the support reaction. Now next one is calculation of P values. So for calculating P values, what are P values? P values are the member forces due to external load. So I'll just again make this truss quickly. Always moving ahead with this calculation of member forces, you first check for 0 force members. Okay. that will reduce your calculation drastically. So step 1 is calculation of support reaction. Step 2 is calculation of member forces, and when we are going for the calculation of member forces, check for zero force members. Okay. So I'll start with this. I'll start with this joint, right? For this joint, there is no support reaction acting, right? So this joint does not have any external load. So both the member forces or both the members will be zero force members, okay? Both the members will be zero force members like this. When you observe this joint, okay, I should name this also. So this is EFGH. E, F, G and H. When you observe this joint G, this external load is in line with this member FG. So force in this second member will be zero force. Okay. Now coming to this joint H, since no force is acting at this joint H or no external load is acting at this joint H, so again the member forces will be 0. In both the member, the forces will be equal to 0. Now we have reduced this entire truss into only one member. And when you observe this one member, since this external load is in line with this member Fg, so the member force in this member Fg will be tensile in nature first of all, and the magnitude of this force will be equal to P. So force in member Fg is equal to P, and this is tensile in nature. Length of the member is L and axial rigidity is R, which is given to us. Now step number 2 is calculating the K values. For calculating the K value, first of all, I want the horizontal displacement at G. So I will remove all the external load and I will give unit displacement at G. So for K values, I'll remove all the external load and I'll give unit displacement at G. So this is E, F, G and H. So what I will do, I will give unit load at G. This is my unit load at G, right? Now corresponding to this unit load, I will calculate all the member forces and those member forces values will be termed as K values, okay? So again, for solving this truss, step number 1 is same. You need to calculate the support reaction due to this unit load. So this is my support reaction due to unit load VE, and this one is HE. This is VH. You can take moment about H equal to 0. So take summation of moment about H equal to 0. So from here you have VE into L, that is the first moment and that is the anti-clockwise moment. So minus VE into L. Then the second moment about H will be due to this unit load. And that moment is again a clockwise moment. Value is 1 into L. This length of the member is also L. So plus 1 into L. And this should be equal to 0. So from here the value of VE comes out to be 1. This is the value of VE. Now for calculating VH, take the summation of all the vertical forces equal to 0. So summation of vertical forces equal to 0. So you have VE acting downwards. So minus VE plus VH is equal to 0. VE is 1. So VH will be equal to 1. So this is minus 1 plus VH is equal to 0. So from here the value of VH comes out to be 1. but VH is acting in upward direction, VE is acting in downward direction, okay. Now next, you need to calculate HE. Take the summation of horizontal forces equal to 0. So only one external load 1 acting in rightward direction. So HE will be equal to 1. Summation of horizontal forces equal to 0. So from here I can write HE is equal to 1. These are my support reactions when I have applied the unit load in the horizontal direction rightwards at G, okay. Now second is calculation of all the K values. Now my dear students, this is the moment where you can really save your time in the exam. Analyze this. What is the horizontal deflection at G? I'll write here. Horizontal deflection at G is the summation of P values into K values into length of the member divided by A into E, that is axial rigidity of that member, okay. If the P value of a particular member is 0, then you multiply it with the K value, the term will automatically be 0. The point is, wherever the P values are 0, for those members you need not to calculate the K values, because when you multiply P value with the K value, the term will be 0 itself. So that can be a shortcut used to solve these type of questions. So just check where the P values are 0, right? So in this entire truss, apart from this member, in all the members, the P value is 0. So we need not to calculate the K values for all these members. We only want the K value for this member FG, okay? Now when you observe this truss, in order to calculate the K value for this member FG, again you can consider this joint G, okay? Corresponding to this joint G, so considering joint G, so this is my joint G, where a unit load is acting like this. This is my unit load and this is my K value, that is member force due to unit load, that is K FG, yeah, and this is the member force K, this is G into H. Although the same story is there, this unit load is in line with this member, so force in this member will be 0. So this can be treated as a 0 force member again, right? So when you take the summation of horizontal forces, you can very easily calculate the K value of Fg. So take the summation of horizontal forces equal to 0. So K of Fg will come out to be 1. So this is the K value for Fg, which is 1. Now for calculating the horizontal deflection at G, you have to multiply by the P value of Fg, K value of Fg into length of this member divided by the axial rigidity. So for all the other members, P values are 0, so we haven't calculated the K values. I have only calculated the K value for this member Fg. So P value for member Fg is P. This is P. K value for this member is 1. Length is given to us divided by axial rigidity. So this is your horizontal deflection of point G. Now we have to simply substitute all the values and get the horizontal deflection. So delta H of G is equal to P. P is how much? P is given to in the question. This is 150 kilonewton. Length is 3 meter. And this is 500 into 10 raised to power 3. So P is 150 kilonewton. So 150 into 10 raised to power 3. Length is 3 meters. Length is 3 meters. So this is 3 meters divided by 500 into 10 raised to power 3. I have to check for this value also. So this is in kilonewton. So we need not to keep this in Newton. So this is kilonewton. So this is kilonewton. This we need not to keep in Newton, so I'll just erase this. So this is 150 into 3 divided by 500 into 10 raised to power 3, and this deflection will come out in meters. Now you check in the question in which units you want the answer. Okay, so you want the answer in mm. So accordingly you can calculate and tell the horizontal deflection of G in mm. So anyways, meters can be written as 10 raised to power 3 mm. So this is 150 into 3 into 1000 meters divided by this is not 50, 500 this is. So this is 500 into 10 raised to power 3 mm. So this and this cancels out. 450 divided by 500 will be 0.9. So horizontal deflection at horizontal deflection at G is equal to 0.9 mm. This is your horizontal deflection at G. Okay, this is your horizontal deflection at G. Few more questions are left for this gate 21 and gate 20. Actually, I am having a serious throat problem, so I cannot speak much. So I'll continue in the next session. I hope you got enough information in this session. My dear students, you have observed this every year in gate examination. You will surely get a question from influence line diagram. Second, a question from truss analysis. And third, a question from the deflection of truss joint. So whenever you are getting the question from deflection of truss joint, unit load method is one of the easiest and one of the most asked method for your examination. So I hope you got enough information for this session. I'll see you in the next session. Keep subscribing our channel, keep sharing our videos, and stay tuned with our IMS Gate Academy YouTube platform. So this is all for today from my side. I'll see you in the next session. Thank you so much for listening patiently.